Example 7, use 3 iterations of the bisection method to determine the root of this fx. Employ initial guesses SL equal to 5 and S upper equal to 10. Compute the approximate percent relative error and also true percent relative error after each iteration. So based on this example here, you asked to calculate the roots. Okay, you must to estimate the roots, and then you must also calculate the true percent relative error, and you also need to calculate approximate percent relative error. Okay, since you asked to calculate the true percent relative error, hence you must to know the true value. So since this problem is a quadratic function, then we can get the true value by using any analytical methods. Okay, remember in introduction I introduced you several analytical methods to calculate the roots for quadratic function. Okay, one is by using quadratic formula, or you can calculate directly by using the calculator. So by using the quadratic formula, we obtain 2 roots for this function. Okay, however, since we are given lower limit, or x is between 5 and 10, okay, so we must to consider the second roots only as our true solution. So we choose this second roots here as our true solution in order to calculate the true percent relative error. Alright. So let's start our first iteration. Okay, estimate the roots of fx using bisection method with initial interval 5 and 10. So remember, this is our lower limit and then this is upper limit. So first iteration, first step, you calculate your f of your lower limit. Okay, so you will obtain this solution, and then you calculate f of your upper limit, then you will obtain this solution here. And then you start the first estimate by using bisection method formula. So remember, bisection method formula is given by SR equal to SL plus SU divided by 2. Okay, so we estimate the first root, so we get SR equal to 7.5. Then we calculate the function of our FSR, we get negative 10.25. Okay, remember, now we have 2 interval. Okay, now we have 2 interval, SL 5, and then we have SU 10, and then we determine also our SR 7.5. So now we have 2 subinterval, first subinterval and also second subinterval, lower and also upper subinterval. So now we need to decide either our true solution or our root of estimation lies between lower subinterval or lies inside the upper subinterval. So we check by using this test. Okay, remember conditional test. Since FSL multiplied with FSR give us negative value, because we have here positive, we have here negative, so this multiply will give you negative value which is less than 0. So it means that the roots lies in the lower subinterval. Okay, based on the algorithm previously. Then we need to set SU equal to 7.5. Therefore, this SU we go to our SR. So now our interval reduce to this new interval here, which is this is our SL, and then this is our new SU. Alright, so this is our first iteration. So this is interval for our second iteration. Okay, so next we can calculate the true percent relative error, since we know the true value minus with our present approximation, and then divide with our true value multiply with 100, then we get 33.23%. However, at the first iteration, we cannot calculate our approximate percent relative error because we just start our approximation. Then we put the dash here. Okay, next we continue with second iteration. So please do correction in your slide, because I find out that there are mistakes here. Alright. Okay, so in second iteration, x now bounded between 5 and 7.5, because now we have our new upper value here. Okay, then we continue estimate our SR by using bisection method formula. So SR equal to 5 plus 7.25, x lower plus x upper divided by 2. So now your roots become 6.25. And then now we calculate our FSR, okay, by plugging into the function, your SR into the function, and then you will get negative 2.9375. Okay, so now again we have two subintervals, so we need to check. So by checking, we found out that FSL multiplied with FSR less than 0. Why? Because FSL previously positive and then FSR negative. So positive multiplied with negative, of course we get less than 0 means negative. Hence, the roots lie in the lower subinterval. Therefore, again, by the test of the condition for this, we set XU equal to 6.25. Okay, so remember previously we have this SL 5, and then we have our new XU 7.25, and then we calculate our new SR, which is 6.25. So now we have two subinterval, lower subinterval and also upper subinterval. Then by checking this, okay, since this condition hold, FSL multiply with FSR less than 0, so we set XU equal to 6.25, means that your XU replace your SR. So now our interval become smaller and smaller, which is close to the true solution. Okay. Alright. Then we also check for a true percent relative error, and this time we can calculate our approximate percent relative error, where this approximate percent relative error come from 6.25 minus 7.5 divided with 6.25 times with 100%. So we get this value here. Alright. Okay, so next we continue our third iteration, since we asked to obtain the solution up to third iteration. So now our x interval for x is between 5 and 6.25. So the results are summarized in the following table. So you can also present your solution by using table. Okay. So at third iteration, we calculate our SR. We obtain 5.625. Okay, and then we check the FSL multiply with FSR, get negative value. But since we only need third iteration, so we can stop our computation, then calculate the true percent and also approximate percent relative error. Therefore, after 3 iterations, the approximate root of fx is SR equal to 5.6250, this value, with true percent relative error equal to 0.06% and approximate percent relative error equal to 11.11%. Okay, next I will show you step-by-step solution by choosing another example for bisection methods.